Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis from Autodesk. On the keyboard I have my buddy Angelo answering questions. And today's topic, I'm going to be talking about inspecting the inspect menu. You've actually seen me use this a couple times in some of my previous live streams, and so I thought I'd delve a little bit deeper and really show the benefits of what the inspect menu can do. So let's jump right in. Looks like people are logging in and saying hi to Angelo. I appreciate that. Okay, so as you can see, I'm in Fusion and we have this inspect menu. And if I click on it, you'll notice the very first one is the measure command. And the I key is the shortcut for inspect. Now, one thing I wanted to point out is you'll notice that the icon is right here. I see a lot of times people will actually click on inspect and then click on measure. You don't have to do that. You can just click right on the little ruler icon across the top. Okay, so when you do that, you'll get this little measure dialog box that appears. And I'm going to go through pretty much every single command in the inspect menu kind of in depth. You'll notice it says selection filter, and by default it's set to face, edge, or vertex. The next one is body and the next one is component. So I'll show some examples of that. Okay, so by default it's going to be set to face, edge, or vertex. You'll also notice we have this precision. So let me go ahead, I'm just going to click on an edge, and you can see that, I just picked this vertical edge right here. It's kind of labeled with a 1, okay, and it says selection 1, and there's the length, 1.181, okay. Now, if I came in here, let me do that again. I'll hit the ruler. If I came in here and did like 4 decimal places, and I click on that edge, you'll notice it still only shows 3. And this, I don't know if this is a bug or something, if it's going to get fixed or whatever. I have mentioned it to other people, but there's a workaround. If you go into your preferences and under unit and value display, you'll notice right here it says general precision is set to 3 decimal places. So I could come in here and say, let's make that 4. I'll say okay. I hope this works. So here you can see that's set to 4, and then when I click on that edge, you'll see it's actually listing 4 decimal places. So if you're doing some high precision parts, and even though you have this set to 4 and it's only returning 2 or 3, go to your preferences and change that unit. And again, just quick review. That was preferences, and then this unit and value display right here. And this actually gives you a lot of options. For example, do you want to hide the trailing zeros? What's the minimum precision when hiding the trailing zeros, etc. So you can kind of see angular. Maybe I want those to always be 3 decimal places, for example. Okay. I'm going to set this back to 3 in this case, just to go through here. Okay, so that's what the precision is for. And a lot of people see these numbers and they're like, what do these mean? It's really the number of decimal places. It's not going to return everything or round everything up to 0.12. It's just basically saying that's 2 decimal places, that's 3 decimal places, that's 4 decimal places. Then this is kind of cool, secondary units. So right now, if I expand this open, you'll see I'm currently in inch. I could do secondary units and say millimeters. And when I click on that edge, you'll see it's going to return it in inch, and it's going to return it in millimeters for me. So I don't have to switch back and forth or do conversions or anything like that. So that's kind of a neat little option right there, is that secondary units. The other thing I use all the time is this restart selection, and you'll see me as we go through what this means. But if I click that, you'll notice that my measurement went away. Okay, and remember that this says face, edge, or vertex. So I could click on a face, and you'll notice that it highlights the whole face, and it tells me what the area is, and it tells me what the loop length is. If you were to, put string all the way around this, and then lay that string out flat and measure it, it would be 133 inches long. Okay, so I'm going to reset. So I clicked a face for that. I'll go ahead and click an edge. We've seen that one work. I'll go ahead and click on a curved surface, and you'll notice it's returning the radius, and it's returning the diameter and the area and the loop length. So very quickly I could come in here and see what size holes these are. So I can see those are 0.63 in diameter. Or I could figure out what a radius is, Now notice this one didn't return a radius or whatever, so that might not be a true radius. Let me try something like this. Yeah, same thing. So, and I know why this is doing that. You'll see this later. Those aren't true radiuses anymore because of something I did to the model. Okay, but if I do like this guy here, let me do another one on the, there's not very many on the outside, but let me do like this guy here. Sure enough, you'll see the radius and the diameter. Now I'll get to why these on the inside weren't returning radiuses. You'll get the answer to that here in a moment. Now also you'll notice when I'm hovering over the radius or the diameter, it says click to copy to clipboard. Okay, so I could click on that guy, and then let's say I'm coming in to do another, let me close out my measure. Oops. I'm coming in to do another fillet, so I say fillet, and it's asking for the size. I can paste, so you'll see it says 0.039, and I know that that is the exact same size as this fillet over here. Okay, so kind of a cool thing with the inspect menu is that you can click to copy into the clipboard. Okay, so now let's kind of take it to the next level. We clicked on a face, we clicked on an edge, we clicked on a radius, we clicked on a hole to get the diameter, etc. Now let's do, for example, I want to know the, if I were to measure this edge, it says it's 1.181, but it doesn't go all the way up to the top, right? Well, I want to know the distance between this plane and this plane. And you can do that. I can just click on that face, and I can click on that face, and it's going to measure the distance for us. And you can see the result right here. And it's also putting it kind of in the center of the whole face, so you can kind of see that black line with the arrows that say 1.22. And it's labeled these number 1 and number 2, and it's given me the information of the area and the loop length. So now I know the exact height between those two planes. Okay, especially if you have parts that have like fillets or chamfers or something like that on there. Let's do the same thing. I want to know the distance from that face to that face there, and you can see it returns the distance. Okay. Okay. Now, what about like angled faces? So for example, I'm going to click on this face, and notice I'm not having to click on, angle or line or distance or anything like that. It's actually returning the results for me automatically because of what I've clicked. Okay. So let's continue on. You'll notice it says show snap points. Now as I hover over things, you can see it's almost like we're doing like a joint command or an align command. So I could actually measure between that point there and that point there, and it's showing me that distance. Okay. Let's see, what else can I show with the measure? I'm going to turn off the show snap points, but basically what it does is it allows you to catch to specific locations, center points of an edge, for example. So you can kind of see when I hover over there, you'll see that little tick mark right where my arrow is pointing. So it's catching to the center there. You can see the little plus symbols on the radiuses, etc. I usually don't show the snap points, but okay. So let's do one of my favorite things, and I don't have a great example of this, but I'm just going to show. I want to know the distance, maybe from this point here to this point down here, for example, and watch what this gives me. It's actually pretty cool. So I'm going to click that point there, and then I'm going to click that point there, and it gives me the distance, like if I were to stretch a piece of string between those 2 points. But that's not what I want. I want to know, like, horizontally how far that is. So that is this option right here, this XYZ delta. So I'm going to go ahead and click on XYZ delta and watch what it returns. So now it's, and let me kind of rotate so you can kind of see what's going on here. If we're looking straight down from the top, it's going straight across, and that distance is 5.143. Whereas if I went, the string between the 2 points, obviously that's going to be a longer distance. And then it also shows the distance in the vertical direction, and then it also shows the distance basically from this point here to that point there. And you can see it returns those deltas for me. So delta X, delta Y, and delta Z. Okay? So I use that one a lot. Now, this only shows up when you're going between 2 points. So if I were to say measure between that face there and that face there, you'll notice it doesn't do the delta. Okay? So what I would do maybe instead is I'll say that point there and that point there. Then it gives me that delta that I'm looking for. Okay? So XYZ delta only exists between points. So another thing that I think is pretty interesting is I'm going to go ahead and earlier I selected the center of the hole, but instead I'm just going to click on that hole right there, and then I'm going to click on that hole right there. And you'll notice I actually get 2 numbers that appear, and actually 3 numbers over here. So it's showing me what the distance is, center to center is 1.969. But then it also returns the maximum and the minimum distance between those. So it's basically measuring from inside that edge to inside that edge there. It's measuring center point to center point, and it's measuring the full extent, the outside of the circle to the outside of the circle. So I think that's kind of a handy little trick if you want to make sure it's going to fit perfectly in your design. Okay. I don't have a good example with the selection filter select body. Let me see. Let me try this guy. I'm going to switch to a different design here real quick. I'll inspect, and let's just go select body. So I might say that body there and that body there, and it tells me the distance, and it's going to be buried, so it's kind of hard to see in here, but it's telling me the distance between those 2 bodies. Now, I personally would probably still leave it on face, edge, vertex, and maybe capture the bottom edge of this part and the top face of that other part, but that's how I would go about doing that. Okay. Give me just a second here. Okay. So the next thing I want to do is, again, I'm kind of walking through the menu. So that was the measure command. Again, I for the shortcut key, and you don't have to go into the menu to click it. Just remember that you can click on the ruler right here across the top to get into that menu. Okay, the next one is interference. I think this one is actually really, really cool. Now, unfortunately, I'm going to show you how bad I designed this model. There are some interferences, but again, the reason for that was because I kind of modeled everything individually and then assembled them together, where I typically design in context, where I use one part to help me design another part to help me design the third part, etc. So you'll notice it comes up with a selection. So let's just measure the whole thing. I'm just gonna draw a box around everything. And then it says include coincident faces. I'm gonna leave that unchecked for now. We can see that it's analyzing 31 objects. And then you have to click this little compute icon. So I'm gonna go ahead and click on that. And it sometimes takes a minute or two to analyze, but it's actually checking for clashing or interferences, and it returns this dialog. So I'm going to kind of move it off to the side, and that way we can kind of see our 3D model. Now it's showing all of the interferences, and if I zoom up, you can actually see it's kind of highlighted some particular areas. Now some of these make sense, and then some of them are kind of embarrassing. So for example, let's go over to this side, and I can see that this plastic insert is actually clashing with the body. So I can also click on these individually. So for example, if I click on number 2, it's going to show me all of the clashes that are happening between the back housing and the center housing. If I click on this guy here, it'll kind of highlight, and this one kind of makes sense. These are those teeth that are kind of engaged with each other, so I'm not really concerned about that one. But this one here is highlighting some issues. So I can actually see if I were to try and assemble this together, it literally would not work. And I can just go through basically step by step. So again, like I said, some of these aren't that important. This is, an imported model, so it might have had the clashing as the person who designed it caused the clashing. So I'm just going to kind of keep stepping through, and sure enough, like that's still inside this plug or whatever. All these individual little pins are clashing. So a lot of these issues really aren't a big deal in this case. I'm more concerned about, here's another prime example, the mount and the glass gasket, etc. So it's showing some clashing going on there. Okay, so let's pick this one here. I think this one's actually pretty cool, and I'm going to digress slightly. I've shown this in a previous live stream, but I know a lot of people are interested in it. I need to fix that. So I'm going to turn off the back housing, and I'm going to click, these are those little wings that I was talking about, and that's that center housing. Well, I can do the edit in place. So I'm going to go ahead and click on edit in place, and that's going to allow me to associatively edit this model without having to open it individually or anything like that. And you can see I'm in this little center housing right here. So I'll just come in here, and maybe I want to, I'll just come in here and say press pull, and let's just move that face in a little bit, like something like so. And I'll just do the top one. I'll leave the bottom one the way it was so we can kind of see the difference. But I just edited that in place. I'll say OK. And now I can run that clash again. So, or the interference, I should say. So it's now updating my timeline, confirming that all of the downstream processes will work. So you can kind of see how it's computing that. A couple of the axes didn't compute, but that's okay. And then let's turn the back housing back on. And I'll inspect one more time. Instead of doing the whole thing, I'm just going to pick the 2 parts that I'm concerned about. So you'll notice instead of 31 selected, it only says 2 selected. And I'll clash. And we can visually see now that I've solved the problem with that top wing. and it hasn't solved the problem for that bottom wing, so I'd have to fix that. But that's the cool thing with this interference check is, you assemble your parts together, you can run an interference, and then if you need to, you could come in and use that edit in place to make those minor changes. Pretty cool command. Okay, so I use interference quite a bit. The last thing with interference was this include coincident faces. So I'm going to select all three of those bodies. I'll say include coincident faces, and let's do a compute. And you'll notice this time I get 2 results, but it's also kind of highlighting the faces that are touching each other. So let me kind of zoom up here. So you see this vertical face is green, this vertical face is green, and the horizontal face is green. So you can kind of see as I'm rotating around, it's basically highlighting faces that are touching each other. And that makes sense, because if you remember us working on this assembly, we basically subtracted the geometry from the center section to make them fit together. So they are coincident with each other. So that's what the coincident face option does. Okay, continuing on. The next one is curvature comb analysis, and this is used especially in surfacing. And let me just kind of show an example of this. So I'm going to click on this guy, and it says edges. You'll notice it doesn't say faces, it says edges. I'm just going to click on this top edge, and you'll see that it creates kind of what looks like a comb. In fact, I'm going to go ahead and select multiple edges, like so. And what this is showing me is basically how smooth this curve is. Is there any wrinkles in it and stuff like that? Now you'll notice it says comb density and comb scale, and this is pretty tiny, so I'm going to crank the scale up a little bit, and you can see how we're now giving my projector a mohawk, right? So you can kind of see what that looks like. And the good news is this is a really nice smooth curve. So I'm very happy that, if this were to get manufactured, you wouldn't see any wrinkles or any oddities or anything like that. You can change the density of the comb. You can make it pretty tight if you need to. But let me show this on another model. So I'm going to go over here, and this is a drill I created in another CAD system in a previous life before Autodesk. So you'll notice there's no timeline, nothing like that. It looks pretty cool, I think. But I'm going to come in here and let's do a curvature comb analysis. And I'll start picking, I'm curious about these edges right here. So I'm going to click on that edge. That looks pretty good. Then I'm going to click on that edge, and something kind of weird happens. Okay, so I'm going to just keep clicking along, and it looks fairly small. So I'm going to crank up the scale here. And now you'll notice I'm getting some weird results. I'm getting some combs that are going vertically, I'm getting some combs that are going horizontally, and then I'm getting these weird jagged edges and stuff like that. And what this means to me is that the end point of this edge isn't really 100% tangent or curvature continuous with this other edge. So it's not as smooth as it could be, and you would potentially maybe even see this edge in the manufacturing process. If this surface isn't, coming in smooth to this surface, and you can almost even kind of see it, how it looks kind of bumped right here. I can even just see it in the model itself. So it didn't really create the fillet as good as it could have or should have in that other CAD system. So the comb analysis is actually really cool to analyze surfaces, for edges basically. To see how nice they look. Now this one you can kind of see it's going down inside. I'll expand that open and see like one's going vertical, one's going in the negative direction, but those actually look pretty good. You can see how nice and smooth that one is there, and you can see pretty evenly spaced on this one in here. Okay, so that's the curvature comb analysis. Okay. Now, for those of you that were observant, notice the inspect menu has a new command in here that wasn't visible earlier. I went from interference to curvature comb. But in here, there's one called validate. And the reason for that is you'll notice that I'm not capturing design history, so it doesn't know how good the surfaces are. I can click on this and it'll check the quality of selected surfaces, and it attempts to heal those surfaces. And even, like, for example, when you're trying to stitch them together into quilts, etc. So watch what this does. I'm going to say validate. I'm just going to click on this body right here, this half of the drill. And you can notice it says checking level is standard. I can do basic or standard. And then there's the option to repair. And when I turn on repair, it's going to look for gaps. It's going to look for small edges, small faces, and remove them automatically. It's going to try and refit those bad surfaces. And you can specify the tolerance in here. I'm just going to leave everything default and say OK. And it's going to analyze that particular body. Now, depending on the complexity of it, it could take a little bit of time. So let's take a look at how long this is going to take. So it says working down here. And then it'll return a little dialogue saying what it did. And this is, it's got some complex surfaces. There's lots of little tiny fillets on this rubber grip area and stuff like that. And it's actually a shelled out model. I should show you what the thing looks like from the inside. So let me glance at the chat while we're waiting for that. So Angelo made a really cool point. He goes, I use the interference to check when I'm making soft jaws in machining. Yeah, very good point there. To see, is it clashing with the stock or with the vise or anything like that. Okay, so here you can see that it's found the number of intersecting or overlapping surfaces was 2, and then it's going to try and resolve that and fix that. And there we go. Okay. I didn't have to do anything. Kind of Fusion did it for me. And let's just figure out which part this is. So that's part of the case. I'll go ahead and isolate this guy so you can kind of see. I mean, there's a lot of stuff going on the inside also. So you can kind of see all those little ribs and features, etc. So that was the validate command. Okay. And the fact that it tries to heal the geometry, I think, is extremely useful. In fact, you're going to learn a couple new commands. Hopefully, you'll learn some new commands that actually fix things for you. And that was one of them, is that validate. The other one we're going to get to is this check sketch. That's kind of a cool one, too. Okay, so we've gone through, we did validate, we did curvature comb analysis. Now we're going to talk about zebra analysis. I'm actually going to bring up some almost made surfaces. So these are the exact same bodies or surfaces right here. And I'm going to switch to the surface and patch the inside. So I'm going to turn off chaining. So watch what happens when I click these edges. I'm going to kind of go around, and when I click here, it's going to create a nice looking surface. It's basically patching all of those edges together. And let me stretch this menu out a little bit. And you'll notice it says edge 1, edge 2, edge 3, edge 4. And even though I started here and worked my way around, it kind of labels it in order. And you'll notice it says connected, okay? Then it also says tangent, and then it also says curvature. And that's why I have 3 of them. We're actually going to build all 3 of these. You'll notice connected means G0 continuity. It's basically just creating a surface that's going to touch this other surface. If I said tangent, it's going to tweak that surface so it's tangent to that other surface. And then curvature is very similar to tangent, but it's a G2 continuity, and it actually kind of mathematically changes how it intersects with this other surface to create a much smoother result. And you're going to see these results. How do you know which one should you use? So this one we're going to leave connected. Okay. Then I'm going to do the same thing over here. I'll pick these edges like so. But instead of G0, I'm going to come in here and say I want those to be G1, and watch what happens. Let me switch back to G0. Watch how the shadows and stuff kind of change as I change that to tangent. And you're going to see as I go around, you know, these kind of shadows sort of changing because it's making sure that it's tangent to these other surfaces. Okay? And you'll see we're going to visualize this a little bit better using the zebra stripes. And then I'll do that one more time. Patch. Clicking the boundary edges. And switching these to curvature. And again, kind of watch what happens to the surface as I change these to curvature. And I can actually, you know, do half of them tangent, half of them connected, or half of them curvature. You know, you have the ability to change these. You also have the ability to change the weight or the influence of how strong that curvature surface should be. Now I'm going to switch my display settings to just shaded. Now you can, just in this example here, you can see the difference, right? With the lines turned off, you can see a pretty harsh line right there where one surface, it's touching it, but it's probably coming in like at a weird angle and then touching this other surface. Whereas these, you'll notice, look much smoother and nicer, okay? Okay, but how are we sure? Well, that's, again, where this inspect menu comes in. So I'm gonna use this zebra analysis. Now, it's asking for the body, so I'm gonna go ahead and click on these faces here. And you see, I turned it into a zebra, okay? And as I rotate around, you'll see a couple things happen. Now, let's talk about these options. I'm going to change the opacity. I'm going to drag this down, and this is actually pretty cool because you can now kind of see the surface a little bit better, but you still see the zebra stripe happening in the background, okay? So you might want to bring this down a little bit. So what is zebra stripe showing me? Well, you'll see these black lines, and you'll notice how these are curved, but they're connected to the black lines or the stripes over here pretty well. But then you'll see, like right here, they're not, okay? So that means that this is not a really good tangent smooth surface. And you'll see that as we continue on. So same thing over here, you really don't see the zebra stripes happening. I personally recommend changing like from vertical to horizontal, and this is a much better example, especially going across this way. Definitely these stripes are not lining up, and so this is a very bad surface, and we already knew that, right? Okay, so let's do this again, maybe with this body over here. So I'm going to go ahead and select these edges, and notice as I move around, these stripes are touching each other. Okay, that means that's a tangential surface. They're connected. You're going to get a nice smooth result, and you can see that over here also. Now I want to analyze this a little bit better, so I'm going to turn on high quality, and watch when I turn that off. You can see it's sort of jagged right here. It's jagged up there. When I turn on high quality, it kind of smooths things out, which I would recommend doing. And then I also would recommend dragging these repeats up, and you can see you can create many more stripes, okay? Now here's something interesting. As I did that, I'm starting to see something kind of weird right here. Instead of nice, smooth, curved lines, it kind of comes to a sharp angle. So I could probably tell that there's something wrong with this surface here that I might want to go back and tweak. You know, and this was a loft, I think, is what I used to create this. So there might be something going on with one of my loft lines. And so I can visually see that that could potentially show up when we manufacture the part. But this is good. We're seeing all of the lines touching other stripes, or all the stripes touching other stripes. Let's go back to vertical in this case. We can kind of confirm that they look good at the top and the bottom also. We can see that those lines are touching. And then lastly, let's do the curvature one. So this was the tangent one. This is the one that was G2 G2 continuity, and we can see that that looks really nice in that direction. Let's go ahead and do the horizontal, and you can kind of see it there. Again, that weird thing happens on this one, so definitely something weird with that surface. But let's go ahead and analyze. Let's just turn these guys on at the same time, just so you can see a little bit of the difference and stuff. I mean, it's pretty similar. Yeah, I mean, they're pretty darn close. So, okay, here's a prime example. Notice this stripe right here is kind of coming up at an angle and just barely starts to turn. Whereas that same stripe here is coming up at that exact same angle, but it's a smoother transition into that other surface. And that is that G2 continuity, where this is just the G1 tangent continuity. So curvature continuity is going to give you much nicer, smoother results. It just mathematically adds a little bit of smoothness to where those edges join. Okay, the other thing you'll notice is I'm moving around, I get like this flashing of the stripes. They're kind of updating as I'm rotating. You can turn on lock stripes, and it basically is almost like it painted it onto the models. So it just allows you to visualize, and then you can unlock if you need to. So depending on where you're at, you'll get a different result. So you can kind of see that. Again, play around with the opacity. In fact, I usually have my zebra stripes turned on as I'm messing with surfaces and stuff. Okay, so I'm going to go ahead and say OK. And when I do that, you'll notice I get an analysis folder. And if I expand that open, there's the zebra stripe. And I get this question a lot. It's like, oh, I did a section view or I did a zebra stripe and I can't turn it off. Well, all you have to do is turn off the analysis over here. In fact, I could have multiple analyses where I'll do just one really quick. I'll just do a curvature map, say OK, and you'll see I have a zebra stripe and a curvature map. And I can turn them on or off individually, or I can turn them all on or off hitting that little eyeball. Okay. Okay. I think that's it for the zebra analysis. So let's go to the next one, which I kind of hinted to right there. I'm going to go back to this drill because it has a lot of complex surfaces. So we just did zebra. I'm going to come back to draft in just a second. Let's do curvature map. So I'm going to say curvature map analysis. And I'll go ahead and click on that surface right there. Again, taking a second for it to analyze it, but what this is going to do is basically show whether the curves are kind of going in a positive direction or in a negative direction. Is there any wrinkles, folds, or anything like that in your surface? And you'll see this once it creates it. Again, fairly complex. It's not only doing the outside, it's also doing the inside. So hopefully it comes back soon. In fact, while it's doing that, I'll check to see if there's any questions. Okay. Yeah, so Angela was saying to see the validate option, you turn the design history off. And unfortunately, this is taking way longer than I wanted it to. Not sure why. And I hope I'm not going to kill it. But just to save time, I'm going to bring up a new session. Just hopefully we can come back to that. Of course, it works perfectly when I practice it, but when you're doing it live, things go south. So give me just a second while I bring up a new session here. And I'll talk about the draft, and let's see if we can go back to the curvature analysis in just a moment. Okay. See, is this? Yeah, it's still thinking. Okay, so I'm going to open up, we're going to do the draft analysis, so I'll open up that part 1 again once this comes back, maybe. Okay. It's really crunching. So I will open up. Let's do the part 1, I think is what I want to do. Okay. And like I said, I'll come back to the curvature map here in just a little bit. Draft analysis. This is where Angelo is probably going to geek out, because this is really, really useful. In fact, some of the stuff, the next few things I'm going to be showing is all going to be on this part. But draft analysis is actually very, very useful because it allows you to check to see if there's any angle in your part. And if I sent this to Angelo to machine, he would want to know, are these pockets truly straight up and down, or is there some kind of draft to these? And if there is, that's probably going to change his manufacturing methodologies. So I'm in my draft analysis. It's asking for the body, so I'm just going to go ahead and click on the body. And then it's asking for a direction. I'm going to expand this open just a little bit. It's asking for a direction. I could click on a face, but am I 100% sure that face is straight up and down? Maybe, maybe not. So I'm going to click on this axis. Now you'll notice I can't click on the axis, but if I click and hold, it's going to probe through and I can select that Y direction. And as soon as I do that, it colors my parts, or my part, I should say. Now you're probably asking, what is all this, right? It's kind of confusing. So here I can specify what my draft angle is. So I'm going to change this to be 0 degrees of draft. Okay, and then you can kind of see some colors have changed. And then I'm going to change this to be 1 degree of draft. Now what this is doing is you'll see that some of these faces are gray. They have 0 degrees of draft. But some of these are kind of like orange and green and stuff. They're colored. In fact, this one looks dark, like dark blue. So this is showing me which faces have draft. So just looking at it normally, it didn't look like any of it had draft. But by analyzing it, I can now confirm that those faces have draft, these faces have draft, that face has draft, etc. In fact, all of these pockets in here have draft, except for a couple over here, it looks like. Interesting. Okay, I'm going to go ahead and crank this up to 2 degrees of draft. And now you can see these kind of turn like a darker red, and these were highlighted. So it's basically showing me which faces, some of them might have 1 degree of draft, some of them might have 2 degrees of draft. In fact, I could increase this in the negative direction. And now you see that those where before they weren't really highlighted, but as soon as I go to 2, these actually have negative draft. So this would be very difficult to machine, and it's kind of hard to see, but they actually angle down. So the top opening is smaller than the bottom opening. Okay, so again, this is showing what angles we're at. 0 degrees, 1 degree, 2 degree, etc. Okay. You can also specify a tolerance zone, and that just kind of helps you specify how close it is. Is it 1.1 or 1.5 or 2 or whatever? You can specify that tolerance zone. Again, you can change the opacity. I typically don't on draft analysis because I kind of want to see that really clearly what's going on. Okay, so draft analysis, very, very powerful. I'm going to turn on high quality. It just takes a little bit longer to calculate, but it'll give you some nice results. So let me crank this back up to 0, and we can visually see what that looks like. Okay, so that was draft analysis. The next one which we'll come back to, is curvature. Accessibility analysis. This is fairly new, and this is really pretty cool. So I'm going to say accessibility. Now, what does this mean? Well, again, if I were to send this to Angelo and he was going to start to manufacture this, he'd want to know, can he actually manufacture it? And is there any undercuts? Is there any issues with this model? So for example, you'll notice it's asking for the body. I'll click on that guy. It's asking for the direction. So once again, I'm going to pick that Y axis, which I can do right here, or I could expand, open the origin, and pick it from there also. Same thing. But notice the results that we get, okay? Everything is green except for we see some red going on in here. So let's kind of zoom up on that. And sure enough, there's like an undercut, like a shelf that goes all the way in here. So he couldn't use just a regular, half-inch end mill to machine this. He'd have to have a custom tool, like a T-slot or something like that. I'm not sure. Angelo would be the one to answer that. He'd have to have a custom tool made to machine this particular area, and now he knows that he would have to do that. The thing I like is you can almost see like this little shadow, this little red. It's actually showing you almost like a projection of these faces coming down. So that's the area that he would not be able to machine. And then if we zoom over here, we can see some weird red and green going on. And again, this is because the faces are tapered or drafted at an angle down, okay? So if he were to bring an end mill straight down, he wouldn't be able to get back into this area over here, and that's what that is showing. So pretty powerful tool, especially if you're doing like plastic injection molded parts, you're manufacturing that type of stuff. This accessibility analysis is pretty cool. Now you can change the direction, and this part doesn't make much sense. You know, you can have it go symmetric or vertical or direction 1, direction 2. And again, that's more for like your plastic injection molding type stuff. So I'll just leave it in one direction. And then just like the other ones, you can change the opacity if you want to kind of see your actual model and stuff like that. So that's the accessibility one. Okay. The minimum radius is the next one. So I'm going to say minimum radius. And watch what happens. You'll notice there's some numbers in here. I'm going to go ahead and click on that, and we can see that a lot of these curved surfaces have turned green. What this allows us to do is to specify, like if I'm limited to a specifically sized cutter, I can actually say what my maximum tool radius is. Okay, so let's just say I have a 1-inch cutter, okay? And then I could come in here and drag this minimum radius, and you'll watch what happens as I start to drag. You're gonna see a couple faces starting to change color. And it's basically saying that I would need a tool smaller than 0.112 to machine that area. In fact, let me just keep going here, and you'll start to see other surfaces and radiuses start to turn red. I'm going kind of slow because I don't want it to suddenly jump on us. And there we go. You can kind of see around the 0.335, you can see these are starting to change. And so I would need a cutter smaller than that number to be able to pretty much manufacture a lot of these holes and pockets, etc. Now obviously these larger radiuses I can still machine with a larger tool than that, okay? But as I keep going, you'll see that more and more things turn red, okay? So I could still use a pretty large cutter to do these radiuses here, but no longer this radius here. And then finally, if I keep going, it'll turn all red. So what is this maximum tool radius? This caused me some confusion at first. It's basically the size that you're analyzing right here. So you'll notice I'm going from 0 to 1, okay? If I said my maximum tool radius was 0.5, you'll notice that this now goes from 0 to 0.5. Okay, so it's basically just, you know, how accurate or whatever you want to say it's, the legend is, I guess. Now you'll notice that some of these are turning like half red and half green. Why is that? Well, all of these faces in here are tapered, and again, that is why when I said measure a radius, this really wasn't a true radius anymore, because the radius was tapered, so it's actually smaller at the bottom and bigger at the top, so it's not a true radius. And that is why this measure, when I did the measure on this radius, it worked fine, but when I did them in here, it did not. And I told you I'd come back to that. And that is why. And this is exactly why you're seeing these kind of banded colors, is because it's tapered, and you could cut it with a 0.338, but you couldn't cut it with a 0.4 or something like that, right? So that's what it's basically showing. So minimum bend radius is actually a pretty powerful tool. Oh, and then the other thing in here, and I'll show you this on another part, because this is kind of a weird part. In fact, let me bring up a different part here. I like this one for the minimum radius. In fact, I labeled it minimum radius. So check this out. Exact same thing. I'll come in here and say minimum radius. We'll click on that guy, and I'll just say the 1 inch, and we'll start to drag. And you can really see here, I'd still be able to cut these radiuses and stuff like that, but I'd have to have a ball end mill that's smaller than that number, right? To be able to cut those fillets in there. So it's a very visual representation of what tool you can use to cut these areas. Now the other thing you'll notice, it says optimal minimum radius is about 0.1, right? And so watch what happens as I start to drag down. I'm still seeing red, but as soon as I get around the 0.1 right there, you can see that most of it's green, but there's still a little bit of red. And if we go down just a little bit smaller, now you can see everything is green because we're below that minimum optimal radius. So that kind of tells you to machine this part with one tool, it would have to be 0.1 in diameter. Then the other thing I like is this sharp edges. If I turn that on, it actually shows me which edges are sharp, and I'd have to have obviously like a flat end mill to do this profile right here and not use a ball end mill. And so again, it allows me to visually see maybe the order that I'm machining this part. If I'm doing a ball end mill for these pockets, I'm going to have to switch to a different tool to do my contour, for example. So that is the minimum radius. Okay. Section analysis, probably my favorite. Let me bring up this guy. I don't need to do the recovery file. Oh, the curvature continuity finally came back. I'm not sure why it took so long. We'll jump to that next. Okay, so this is something we've worked on previously, and I'm going to go to inspect section analysis. Now it's asking for faces. Now, what a lot of people don't know is that you can actually select a face, or you could select a plane. So I'm going to click on this plane, and it's going to slice through or section through our model, and we can visually see inside our model. Okay, now here's some cool tips. You'll notice it says faces. Okay, so I can actually click, for example, on a face like that, and it'll cut through. I can also click on a radial face, and it will slice through the center of that radial face. So let me kind of drag this direction. So for example, we've got this this motor, the stepper motor in here, and we've got the little drive shaft. I can just click on this motor, and it's going to slice exactly through the center of that motor. And I'll be honest, I didn't know that until fairly recently. I was always like pushing and pulling this little arrow until I got it kind of where I wanted it to be. But if I want to be exactly through the center of something, like this guy here, I just click on it and it's going to slice right through the center of it. Okay, as I'm zooming around, you can see all of the parts are individual different colors, etc. And as I zoom up here, I can actually see they're hatched, but this one almost has like a double hatch. And here's the embarrassing part. This part is clashing with this other part right here. And that was one of the things that showed up in the clash detection or the interference detection. Okay, so I would have to fix that. In fact, I can visually see this, maybe this whole assembly of the glass and the gasket needs to be over here a little bit. And so I could edit in place and fix that. But what I like about section view is I can visually see that sure enough, I have enough clearance in here that this part fits perfectly. It's butted up against the back of this part. It's a really cool way to analyze and check to see what everything looks like. Okay, so same thing here. The hole that this goes through has enough room. Now you'll notice it's a little kind of hard to see sometimes. So you have some option in here. This section color says from component or custom. And if I change it to custom, I can pick whichever color I want. So I could even do like a light white or something like that, like a gray. I personally picked like a bright yellow because it kind of really stands out. Okay, you can also turn off show hatching, and it just becomes a solid. And this is kind of how I usually look at it. I usually have hatching turned on at first to look for the clashing, that kind of a thing. But then I might turn that off and analyze it kind of in this method, looking at it from front view or top view or side view, etc., and just analyzing everything and making sure everything looks correct, which it does. So section view, extremely useful. Now, check this out. I'm going to go ahead and say, okay, actually, let me show the last couple things. You saw you can drag the arrow to slice through it. You also have these little wheels here, and so you can rotate and change the direction of the section very quickly. So now we're slicing through vertically through the model, almost like an MRI or a CAT scan or whatever kind of a thing. Okay. So you can rotate in multiple directions. Now we don't do like a Z bend or anything like that type section, unfortunately. You can do that by actually like physically splitting the bodies using some planes and stuff like that. But the section is just one plane. However, you can have multiple section views. So you'll notice under my analysis folder, I can click on section 2. Turn that guy on. I can turn on section 1, turn on section 3. So you can go back and forth between these. You can have multiple sections in there. Okay. I'm going to go ahead and turn off. Again, the question I get quite often is, how do I turn off my section view? Just hit the little eyeball next to it and it'll turn off. The next one under section analysis is center of mass. So I'll go ahead and click on center of mass. And I'm just going to click on this stake down here. In fact, I'm going to click way down here. I'll say OK. And you'll see this little center of gravity icon appear. So that is where this part, this stake part, would balance perfectly, is at that center of gravity mark. And you can actually measure where that is and all that kind of stuff. You could pick on it and measure it from a distance to another point or whatever. And you'll notice that it puts it into the analysis. I can delete it if I don't want it there. So that was just for that part. Let's do it for this part here. There's 30 selected. I'll say OK. And we can now see that center of gravity mark or center of mass mark is basically right there inside this whole assembly. And that kind of makes sense, right? It's pretty heavy right here, but we've got some mass going on down here. And so it makes kind of sense that it would be in that general area. Okay, and just to show you how cool this is, I have a bunch of parts turned off, like the, let me close this guy up. I got some screws turned off, I'll turn those guys on, some connectors, I think the whole board. So I'm gonna just turn all of these guys on. In fact, I should just be able to say, let me see, no, okay, I'll just do it this way, running out of time. So I'll turn all of those parts on, and then I think that's about it. So laser diode, yeah, so I turned on the circuit board, which I originally had turned off earlier. So there's that center of gravity. Let's do that one more time. Center of mass. I'll draw a box around the whole thing. So instead of 30, now you see 102, because it's actually all of the components on the circuit board, etc. And it should analyze. You can see that they're slightly different. Let me rotate. Let me turn these guys off so you can kind of see what's going on here. So there's the two center of mass, and you can see that they're off just ever so slightly. So by turning on that circuit board and that kind of a thing, it actually made it a little bit more forward and down. So pretty cool, I think. Okay. The next one I want to talk about is this guy, where time flies, man. Under inspect, under center of mass, we just did that. There's this component color cycling toggle. So you'll notice this assembly, everything is gray, but I'm going to come in here and say component color cycling toggle, and you can see it kind of colors them these pastel colors. But also notice my browser, and also notice my timeline. So I see some red, and then I see kind of some purple, some blue, and then some more red going on here, etc. What this is basically showing me is anything that's kind of colored red has to do with this red part. So we can kind of see we designed all of this geometry with the holes and the chamfers, and we mirrored stuff and combine parts together, etc. That all has to do with that particular component. I can also see that it's the frame. So let's just go ahead and activate the frame, and sure enough, there are all of the steps just for the frame. So it's a very visual way to see, here's all of the steps for this part right here. But then as I continue down here, we're going to start to see different colors. So it looks like I came in and I added some threads to different parts, like the pins and the holes, etc. So it's kind of a neat way to see what is going on in your timeline and what is it related to. Now, I personally like to, activate the particular component and work with it in a simpler timeline. But if you're looking at it from the top level, this is kind of a cool way to see what's going on. And it is a toggle, so I could come in here and click on it again, and it goes back to gray. So that's component color cycling toggle. Okay, then the next one here is check sketch. So I'm going to create a sketch, and I'm going to insert in like a DXF file or something like that. So like an SVG or a DXF. I'm going to bring in a DXF, and I think I have one. Yeah, I'll just bring in this DXF here, because maybe I want to cut this out on, out of sheet metal or something like that. I'll go ahead and say okay. And I brought in this DXF file. Now you'll notice I have show profile turned on, and it's highlighting these areas as those being closed profiles. But I want this dog to be a closed profile too, but it doesn't seem to be. And I've shown a trick in the past where you can kind of like draw a line, across the profile, and notice that shaded. So that's cool. I know that area is okay, but that can be kind of time consuming. Like I would probably cut through here, and okay, so that shaded, but so did this over here, which is kind of weird, and this didn't shade. So you can see this could take quite some time for me to figure out what is going on here. So under the inspect menu, there's this option called check sketch. So I'm going to go ahead and click on that. Now it doesn't look like it's doing anything, but you have to be patient. And now you'll notice after just a few seconds, it actually created these dots that appeared. And let me kind of zoom up on this particular area, and guess what? It's not a closed sketch. And that's what was causing the problem. If it's open, it's not a closed sketch, and so you can't extrude that or whatever. So I might come in here and use some tools, like let's just try the extend tool, okay, and then maybe the trim tool, trim that guy back just a little bit, okay. Now I can't remember where the other part was, so I'll just do that check sketch again. And yeah, so I will get, I saw a text from Angelo about the curvature. I am going to come back to that, so don't worry. So I'm going to check this sketch. It's going to, man, I am not having luck today. Gosh, guys. So I'll come back to the sketch. So here is the curvature map. We'll come back to the sketch here in just a second. So what I did is I said curvature map analysis, and I picked on this body, and you can see some weird colors. Now you can see like really nice smooth green up here, but then we get this purple, some green, some purple, and it's kind of like, what does this mean? Well, it's basically showing how smooth the surface is, the curvature of the surface. And this obviously is like almost like a cylinder, so it doesn't have any wrinkles or anything like that. But then we're connecting to a blend here, and this is more of like an organic free form type deal right here. And so that's why we're seeing some of this feedback. So let me talk about this menu. I can change the scale of this. I'm going to kind of scale this down. So what it's showing me now is where is the tightest areas of curvature. So I can see like right here and right here, right here. So this is where, you know, the tightest areas are. And as I scale this up, you know, you can see we're starting to get like some wrinkles going on in here. So I might want to be aware of this surface and make sure that it looks really nice as I'm designing that surface, because as I scale this up, you can start to see we're getting kind of like purple and then red and then purple again and then red and then purple again. So to me, that almost looks like there's a wrinkle or a pinch in there. Okay. Again, I could also do the opacity. So we can, you know, but it doesn't make much sense in this case. I'm going to turn on high quality. Watch what happens when you do high quality. It'll smooth things out. Hopefully it doesn't die on me. But it'll create a nicer looking result. And then, I probably shouldn't have done that. The type is Gaussian. You also have max and min. I'll show those. I probably shouldn't have done the high quality because it's going to analyze that whole surface again. Okay, there we go. So you can kind of see it smooth things out. I get a nicer result. Okay, if I change from smooth to bands, it kind of gives you, you know, basically 16 colors instead of 6 million colors or whatever. And then you have Gaussian, and then you have principal minimum and principal maximum. So I'm going to click on principal maximum. And again, this kind of shows, let me change the scale here, where it's a very, you know, visual representation of where's the tightest surfaces, right? And so it kind of makes sense that this fillet, instead of being nice and smooth like this surface is over here, it's you know, a max surface. It's getting curved very quickly, and as I keep dragging this up, I can visually see what that looks like and where the tightness of the curvature is. Okay, let's do principal minimum. I don't really get much going on with this. So again, at 0, everything is red, but as I scroll this, so it's almost like the opposite of the maximum. So I can kind of see where potential issues could be on my surface. I usually use this one I would say 90% of the time. And then I use maximum the other 10% just to kind of see really where the tightness is. And I would come back and maybe smooth this surface out if I could, right? So that is the curvature map analysis. Let's finish up here real quick. Actually, let me do insert DXF. We'll do the dog DXF. And came in upside down. Whoops. But that's okay because I did it on the front plane instead of the top plane. Okay, so I'm going to do that check sketch again. And notice it says a sketch needs to be active. So I'm going to go ahead and edit that sketch. And let's just rotate this real quick. Check sketch. It's going to analyze it. And so, and just to speed things up, instead of like extending and trimming, I'll just draw a line like that. Finish sketch. Oops, I didn't mean to finish sketch, sorry. Edit that sketch again. Oh, jeez. I'm having a great day. Okay, the other one was over here somewhere, and actually I just saw it. So there's a gap right there. So let's just go ahead and fill in that line from there to there. And now you'll notice that that shaded in. So it was those two gaps that was causing this to not be a closed profile. I'll try the check sketch one more time and see if it returns anything else. And sure enough, it does. I see two little dots right there, but this guy's shaded in. So I wonder what that means. So I'm going to zoom up and I don't see a gap, which is weird, but I do see these two little dots. And that looks like a solid line. So you might say, well, what's going on here? Well, I would draw a box around that region and it looks like there's a line. So I'm going to hit the delete key on my keyboard. And sure enough, there was a line on top of a line, which can sometimes cause issues, especially if you're doing like a plasma cutter or water jet or something like that. It might want to go back over that area and burn it a little bit longer, for example. So I would check your sketch to make sure there's no overlapping geometry. And now I have this. I'm able to extrude it the way I want to. And that is the check sketch option. Okay, so let me review here really quick. We did the measure, we did the interference, we did the curvature comb, zebra analysis I use a lot for surfacing. Draft is great for plastic parts and for machining to make sure the part that was sent to you didn't have any draft to it. Curvature, again, more for surfacing. And then probably my favorite are the accessibility, the minimum radius, and the section analysis. I think these are extremely powerful tools. Now the last one I want to show, somebody asked, how do you find out the mass properties of a model? You'll notice that's not in here, right? So if I click on this guy here, I can see that it's under this body right here. And if I right mouse click, there's the properties. And if I click on that, it's going to return the properties of this model. So the area, the density, the mass. Now, currently it returns it in ounce mass, and there is not a way to change that. So you have to convert it. I don't know why, but I wish I could say like pound mass or whatever. So there it is. What's the physical material, the volume, etc. But what's really cool is notice it says center of mass. It figured it out for you. And if I expand open this bounding box, this is actually pretty useful. It's telling me what the length, width, and height is in a bounding box. Okay. Okay, make sure everything's going good. Okay. And then I can expand open the moment of inertia at the origin and at the center of mass. It tells you exactly where that is, for example. So hopefully that answers the questions. Now I've gone a little bit over. So good news is we made it through, barely. I apologize for, I don't know why it took so long to do the curvature map, and then I had a crash, which is pretty rare for me, so I must have too much stuff going on my computer right now. Bad news is I am actually going to be gone for the next 3 weeks. I'm finishing up my sabbatical. I was supposed to get a 6-week sabbatical. I got basically 1 week in, and COVID hit, so we're trying to finish the sabbatical up, so I will not be doing a live stream the next 3 weeks. There are other live streams happening. Make sure you're watching the YouTube channel for that. But in the meantime, use Fusion. Try different things out. Challenge yourself. Maybe go back and watch one of the live streams we've done that you haven't seen before. So keep using Fusion, and remember, with Fusion, you can make anything. Thank you.